Hi, in this video I'm going to discuss Edexcel IAL Mathematics Mechanics M3 paper January 2021. All the questions will be discussed in this video. Okay, so the first question, this diagram is given. It's a graph y equal 1 over x graph. The region R, they name this shaded region as R. The region capital R shown shaded in figure 1 is bounded by the curve with equation y equal 1 over x. So this is the equation, the curve y equal 1 over x. Y equal 1 over x. The line with the equation x equal 1 and x equal a. So the other way I put it, this is x equal 1 here. This is x equal 1 and this is x equal a. So that's the shaded region. Now what they are doing it, a uniform solid S is formed by rotating R through 2 pi radians. So they are rotating this shaded region about x-axis through 2 pi radians, that is 360 degree. So when you rotate it through 360 degree, 2 pi radian about the x-axis, you will get a shape like this. Something like this shape, you will get it. The shape that you are going to get when it is rotated about x-axis will be something like this. Okay, so the question is, find the volume or show that the volume of S, the shape of this solid is named S. Volume of S is pi into 1 minus 1 over A. Okay, so this is actually in physics, you should be able to apply the physics principles in different real world applications. But in mathematics, you should know the method. Simple methods are there. You should know the method. So this type of question appeared several times in the past papers again and again. So the method here, they ask you to find the volume of this solid S. So to find the volume, what we do, we don't know the equation of volume, anything that we are going to find it. So what we do, we try to find the volume of the whole solid by summing, adding different volumes of known shapes that can fill up the whole volume. So the suitable smaller scale of solid or three-dimensional solid that could be imagined to fill the whole given S is a disc shape. We'll imagine a smaller disc inside this one, something like this way. So we'll imagine a smaller disc of thickness dx at a distance x from the origin. So for this disc, the radius is going to be this one. This is the radius. That's y. We can name it as y, the radius. Because this is on a Cartesian coordinate. So the radius of this disc is y and it is at a distance of x from the origin. Okay, so we know the equation for the volume of a smaller component that we imagine inside the given solid S is a disk. Its volume is given by V is equal to, we know if we have a smaller disk, something like this shape, a smaller disk, something like that, which has thickness dx and the radius y, we know that pi y squared dx is the volume. So the volume of this smaller disk is delta y pi y squared dx, pi r squared h. That's the thing, the thickness of the disk or thickness of a much smaller cylinder, something like that. Or disk is a better word, like a coin. Yeah. So the volume of it is pi y squared dx, but we have the equation that relates the y, the radius and the distance of the disk that we imagine from the origin is x. So y is equal to 1 over x. So pi 1 over x all the squared dx. That is the volume of this smaller disk. Okay, so we are going to imagine there are many disks, several disks that we can imagine inside like this, and we add the volume of each and every disk from this end where x equal 1 to x equal a, we will get the volume of the solid S. This is named S. This given solid is named S. So we can find the volume of the solid S by summing or adding volume of each and every tiny disk we consider inside, and we add all the volume of them. We should be able to find the volume of the solid S. Okay, so that means we need to add it. So the volume of the whole S, the volume of the S is given by sigma. We need to add it pi 1 over x squared dx, or that means I can write one more sentence before that. Volume of this one V is equal to delta V. This is not y, this is delta V. So that is sigma delta V. That means we have to add again many different disks that we imagine inside the given S. Okay, so that means V is going to be sigma pi 1 over x all things squared dx. Okay, so here up to what limit are we going to imagine the many different disks? That is from x is the variable, from x equal 1 to x equal a. And we know that when there is a variable with summation, that means it's going to be an integration. So that's going to be integration. So that will be integral pi 1 over x all things squared dx. X is varying from 1 to a. Solve it, you will get the volume. That's the final answer. So that's going to be pi integral 1 to a 1 over x squared dx. So when you integrate it, you know 1 over x squared, x to the power minus 2. You know the integration, x to the minus 2 means x to the minus 2 plus 1, that is minus 1 over x. So it's going to be pi, that I can put the minus here, 1 over x 1 to a. So we'll continue here. V is going to be minus pi 1 over a minus 1 over 1, that is 1. Bring the minus 1 inside, that's going to be pi into 1 minus 1 over a. That's the first part. We got the answer for the first part of question number 1. Okay, so now B part, find the x coordinate of the center of mass of S. Okay, so that means x coordinate of the center of mass of S means from the origin, what could be the distance of the center of mass? That is the question. What's the distance of the center of mass of this solid S from O? That's the question, right? Okay, so for that, first one, we must know what is the mathematical definition of center of mass. Okay, so we imagine, like, you know, when we consider center of mass, it's a distance from a particular point. That point, normally we can take it as the origin of the Cartesian coordinate. So imagine a Cartesian coordinate in which there are many different particles. Imagine the mass of this particle is m1 at a distance x1 from the origin. This distance is x1. There's another particle, that mass is m2, its distance from the origin is x2. There's a particle m3, its distance from the origin is x3. Like that, there are n different particles, and mass of the nth particle is mn. Its distance from the origin is xn. Okay, so what is the center of mass, or what is the distance of the center of mass of this system of particles from the origin? If they ask, mathematically it's defined like this: the distance of the center of mass from the origin, because all these distances of m1, m2, m3 are measured from O. So we give the center of mass of the system of particles also from the same point O. So the distance of the center of mass is defined as x bar is equal to m1 x1 plus m2 x2 plus up to mn xn over m1 plus m2 plus m3 up to mn. So that means mathematically that is sigma mi xi I is equal to 1 to n divided by sigma mi I is equal to 1 to n. That's the mathematical definition of center of mass of system of particles. Not only for system of particles, system of objects also we can imagine if we know the specific center of mass of each and every objects. So this is the mathematical definition. So here you can see sigma mi, that is the total mass of the particles, but here xi is a variable, is it? Xi is a variable, different particles at different distance. So depending on the shape, we could be able to, if it is the xi is in the form of a mathematical equation, if it is in a function, we should be able to integrate it. So the numerator could be integrated depending on the the relationship of xi. If it is in the form, if it is in a function, we could be able to integrate. So that's the idea. We are going to use it here also. You must know the mathematical definition of center of mass. Okay, so here we are going to use the same idea, the same method here also. We need to find the center of mass of the S. There we are going to consider the center of mass of many different disks inside the given shape solid S. The distance of the center of mass of this disk from O is x, because you know it's a uniform disk. Its center of mass will be at the center of the disk, which is at a distance of x from the origin. So the mass of this disk, we can find it, delta m, I can call it as delta m, is equal to volume of it, delta v, that is pi 1 over x, that is the radius, pi y squared, pi y squared dx, that is the volume of the disk, into rho. We can take it as density, but anyway rho will get cancelled. Sometimes in mechanics books they don't put rho, they take it as one unit volume, unit density, but doesn't matter, we can take it rho, but anyway it's going to get cancelled. So this is the mass of the disk that I consider at a distance x from the origin. So its center of mass is at distance x, right? So we imagine several disks like this inside the given solid S. So according to the definition, mathematical definition of center of mass, x bar is equal to the distance of the center of mass of the S, the given object, from the origin O, is given by sigma mixi, or delta mixi over sigma m delta mi. So I can call it as delta mi. Delta mi is the mass of a small disk. Okay, anyway, the denominator sigma delta mi, we know that sigma delta mi is equal to the total mass of the solid S, means total volume of the solid S into density. Total volume, we found it already in the first part, that is pi into 1 minus 1 over A into rho, that is sigma delta mi, the summation of the total masses of the disk we imagine inside the solid S. Okay, only thing we need to solve the numerator. So x bar is equal to the center of mass, distance is equal to sigma pi y squared, y equal 1 over x, so 1 over x squared dx rho into xi, means the distance of that particular disk, center of mass of it is x from O, so into x over pi 1 minus 1 over A rho. So it's simple now, rho anyway going to get cancelled, pi will get cancelled, so it's a summation with a function, means it's going to be a integration. So we need to decide the range of the x, that is x is going to be x equal 1 to x equal a. So x bar is equal to integral of 1 over x squared into x, that is 1 over x dx, from 1 to a over pi into 1 minus 1 over a. Right. So x bar should be there. Okay, we know that when we integrate this one, it will going to be ln, natural logarithm. So ln x with limits 1 to a over pi got cancelled, pi got cancelled. So 1 minus 1 over a, that is x bar. Okay, we'll continue further solving it. So that is going to be ln a minus ln 1. ln 1 is 0. So that is going to be ln a minus ln 1. When I substitute the limits, ln 1 equals 0 divided by a minus 1 over a. So that a will go up. So finally x bar, I'll write it here, the final answer, x bar is going to be the distance of the center of mass of this given solid S is going to be a ln a over a minus 1. That's the answer for the second part. So in all questions where you get questions related to center of mass, the same method. So in mathematics, you must know the methods. In physics, you should be able to have the knowledge or skill to apply the physics principles in different real world applications. But in mathematics, in mechanics, the method you must know. The method is the important thing. Okay, so the second question based on gravitational force, gravitational pull. A particle P of mass m is at a distance x above the surface of Earth. So I drew the diagram. X above the surface of Earth means this is x. From here to here, this is x. The mass of the particle is m. The radius of the Earth is capital R. This force is directed towards the center of the Earth. The magnitude of this force is inversely proportional to the square of the distance of P from the center of the Earth. Okay, the radius is R. So at the surface of the Earth, the gravitational acceleration due to gravity is J. The Earth is modeled as a fixed sphere of radius R. Show that the magnitude of the gravitational force on P, the gravitational force F, that is the only force acting on it. So the gravitational force, we had to show that A part, mgr squared over x plus r, all things squared. Okay, so here they are saying two information given. The force is directed towards the center of the Earth, and this force is inversely proportional to the square of the distance from the center of the Earth. At the same time, they are telling on the surface of the Earth, the acceleration of free fall, or the gravitational acceleration is symbol J. Okay, we'll use this information. So here the force F, when it is at this distance, the force F is inversely proportional to distance from the center of the Earth, means proportional to r plus x all things squared. You know, when you convert the proportionality into an equation, there will be a constant, that is k times 1 over r plus x all things squared, or I can put the k here. Okay, that's the force, but only we have to eliminate k. For that, they are telling on the surface of Earth, the acceleration of free fall, or the gravitational acceleration, is g. So when I use the same principle for when the particle just reaches the surface of Earth, not touching the surface of Earth. If it touches the Earth, then there will be a normal reaction. So when it just reaches the surface of Earth, that time the force acting on it also proportional to distance from the inversely proportional to distance from the center of the Earth. So that must be equal to k over r squared, inversely proportional. So the constant is the same constant, inversely proportional to r squared. At the same time, they are saying the acceleration, the gravitational acceleration is on the surface of Earth is g. So I can use the Newton's second law, F equal m mx double dot. We can use F equal ma, symbol A we use for acceleration normally on all books, but in your mechanics M3, symbol A is used for amplitude in simple harmonic motion, and F equal mx double dot, x double dot is the acceleration. So on the surface of Earth, the force is k over r squared. The mass of the object is m, this is g. So from this, k is equal to mg r squared. So substitute the second, that is the expression for k in the first equation, you will get the answer. So f is going to be, substitute 2 in 1, instead of k substitute mg r squared over r plus x all in square, or x plus r all in square, either you can write. Okay, so this is the answer for the first part, question number 2. Okay, so big part, a particle is released, the question number 2, big part. A particle is released from rest from a point above the surface of Earth. When the particle is at a distance r above the surface of Earth, its speed is capital U. Air resistance is negligible. Find in terms of U, symbol G and capital R, the speed of the particle when it strikes the surface of Earth. Okay, it's nothing actually. We can do this question in 2 different methods, or we can approach this question in 2 different methods. One, by using energy equations. The other one is by using Newton's second law, F equal mx double dot, F equal ma Newton's second law. So either way we can do, I'll do the both methods. The difficult part is the force is not a constant. It's a variable force depending on the height above the surface of Earth. If it is a constant force, normally in physics unit 1 paper, the question based on a constant force. When we are using the energy equations in physics, I am telling, the same idea, the same principle we are going to use it. For example, a ball is dropped down from a height h above the Earth. So the mass of the ball is m, means the only force acting on it is the gravitational pull mg. So when the ball is released from a speed which is rest, or we can say it's thrown out down at a speed u, it's thrown down at a speed u. What's the speed when it reaches the ground? Same idea. So here we know the force acting on the particle is constant, but we can use the energy equation. So the energy equation we say loss in gravitational potential energy equal gain in kinetic energy we can use, but in mechanics M3 we are not dealing with gravitational potential, so I don't want to go in that way. So instead of gravitational potential we can say work done by the gravitational pull. So there's a force acting on it, that force is the gravitational pull. So the gravitational pull is doing work on the object. Because of the gravitational pull acting downwards, when the ball goes down, it's gaining kinetic energy. So we can write like this: work done by the gravitational pull equal to gain in kinetic energy. You know, there's a force acting on it. When you are pushing a trolley, you are applying force. Force means you are doing work. Work done by you equal to gain in kinetic energy of the trolley. Like that, Earth is doing work. The gravitational force is doing work. So work done by the gravitational pull is equal to gain in kinetic energy. Work done by the gravitational pull means the force exerted by the gravitational field, that is mg, into the distance is moved is h, equal to half m v squared minus half m u squared. That's a gain in kinetic energy. But here the force mg is constant, but here the problem is the force is not a constant. But we are going to use the same principle we are going to use, but the force is a function of distance from the surface, or force is a function of the distance h, distance x or h, whatever I use. Therefore, we have to use calculus integrate. That's the only difference. Otherwise, the principle is exactly the same what you learn in physics, those who are doing physics. Okay, so when I use that idea here, we need to define the directions, because we are going to use limits in this question. when you are integrating, and we should define the direction, which direction we are taking positive. Normally we take the height is measured from the surface of x, so the x along the direction of x is taken as positive, so the dx will be taken this way, which is positive. Okay, so when it is at a distance x above the surface of Earth, at that moment the force acting on it is F equal, we already found it, F equal mg r squared over r plus x all things squared. So if it moves the distance delta x, what is the work done by the gravitational force? That will be delta W, the work done by the gravitational pull, is equal to, at that point the force F is equal to mg r squared over r plus x all things squared into the distance it moves dx, that is mg r squared over r plus x all things squared times dx. But here we know that the force is acting towards the earth. Dx, we are taking x this direction, means dx also taken in that direction. So they are in opposite direction. So there will be minus sign when we substitute in the energy equation. So here there must be a minus sign because x is measured along this direction, dx is measured along this direction, force is acting opposite. So there must be a minus sign. I would use the same principle. Work done by the gravitational pull equal gain in kinetic energy. So gain in kinetic energy. So work done by the gravitational pull is equal to force, that is minus mg r squared over r plus x all things squared dx is equal to, that's the work done when it moves through a smaller distance dx, is equal to gain in kinetic energy. So when we consider the motion from r to surface, that at distance of, they are saying when it is at a distance of capital R from the surface, its speed is u, find the speed v when it reaches the earth. So we need to find the total work done of it, so that should have an integration. X is varying from R to 0. Understand, because this is the expression for when it moves through a smaller distance dx. So there is a minus sign because the direction of dx is taken along the direction of x and the force is towards it, so they are in opposite direction, so there is a minus sign. So the range, so the total work done when it moves from r, distance r above the surface of earth to surface. So r above the surface of earth to surface, the total work done provides a gain in kinetic energy. How much is it? It was initially at a distance r, the kinetic energy is half mu squared. Now half mv squared, which increased. So gain in kinetic energy half mv squared on the surface of earth minus half mu squared at distance r. Solve it. That's all. When you solve it, you will get the final answer. Okay, so you know this m will get cancelled, m, non-zero values we can cancel them. Here 2, we can cross multiply. So it will become, on the left side, if I write it, it will become minus 2gr squared integral of dx over r plus x all things squared is equal to, this is the limit same, r to 0 is equal to v squared minus u squared. The 2 I cross multiplied, so that 2 has come here. M got cancelled, so gr squared. Okay, you know the integration of this one, that is integration of 1 over x plus a to the power n dx is equal to, we can consider it as x plus a to the power minus n dx. That will become x plus a to the power minus n plus 1 over minus n plus 1. You know that integration. Okay, I'm going to use that idea here. It's going to be minus 2g r squared r plus x all this squared. When it goes up, it will become r plus x to the power minus 2 dx. Integration, I can put integration, sorry. Integral r to 0 is equal to v squared minus u squared. So this will become minus 2 plus 1 is minus 1. There's a minus 1 will become denominator. That minus 1 and this minus will get cancelled. So that's going to be 2g r squared times 1 over r plus x. The limits will be from r to 0, v squared minus u squared. Again I am saying this minus 2 plus 1, that is minus 1, r plus x to the power minus 3 means 1 over r plus x. That minus 1 will be written in the denominator. That minus 1 will get cancelled with this minus, so 2g r squared, and this will be there. Okay, substitute the limits. So 2g r squared, 2g r squared into 1 over r. When you substitute 0, when you substitute r, it will be 1 over r plus r, 1 over 2r equal v squared minus u squared. Anyway, 1r, 2r, r squared will get cancelled. So it's going to be 2gr so that's going to be v squared minus u squared. So that 2 minus 1, 1, that is 2 and 2 get cancelled. So gr equal v squared minus u squared. So v is equal to u squared plus gr to the power of half or square root. That's the answer. So you know that when it moves towards the speed, the numerical value or the magnitude of the speed is increasing because of work done by the gravitational pull u squared plus. So that means it's increasing. Okay, so the second method of the same part B, we can use the Newton's second law. F equal mx double dot. Ma we normally use in physics, but here mx double dot. Okay, here we take a direction is important because it's a vector equation. Always we take along the direction of x because x is measured from the surface. So we take along the direction of x positive. The force acting on the particle p is towards, so it's going to be minus. Now it's going to be minus mgr squared over r plus x all things squared is equal to m. Acceleration means dv over dt. We know that acceleration means x double dot equal dv over dt, that is dv over dx into dx over dt. Dx over dt is v, so this could be written v dv over dx. Dx over dt is v dv over dx. So it could be written as m v dv over dx. M will get cancelled, so it's going to be minus gr squared over r plus x all things squared equal v dv over dx. Okay, so it's a first it's a simply differential equation, so we need to solve it in terms of v. So we'll integrate it now, rearrange it. So it's going to be my integral of minus gr squared, we can take it out, gr squared 1 over r plus x all things squared dx is equal to integral of v dv. We need to put the limits. When the x is at r, the speed is u, it's given. When the x is 0, because x is measured from the surface, x becomes 0 on the surface, we need to find the speed v. That's all. So you know how to integrate it. Already I did it in the first method. It's going to be minus gr squared 1 over r plus x, there will be minus sign. So that minus sign will get cancelled with this minus, so it will become plus. The limits from r to 0 equal, this will be v squared by 2. The limits are from u to v. Again, r plus x all x squared, when it goes to the numerator, r plus x to the power minus 2 plus 1, r plus x to the power minus 1, and the denominator there will be minus 1. So integration, I already told that's the same way. So that minus 1 and this minus get cancelled, so gr squared. So solve it, gr squared. When you substitute 0 here, 1 over r minus 1 over 2r is equal to, here v squared by 2 minus u squared by 2. So this is going to be gr squared into r will get cancelled, so it will be gr into 1 minus 1 over 2 is equal to v squared minus u squared over 2. So 2 minus 1, 1 minus half is half, that 2 and these 2 will get cancelled. So gr is equal to v squared minus u squared. So v squared is equal to u squared plus gr. So v is going to be square root of u squared plus gr. We'll get the same answer earlier also. So either way, most of the questions, even in simple harmonic motion, you can do the same thing. You can use the principles related to work done by the elastic force, but we don't use that way here because you have the equation elastic potential energy. Elastic potential energy in simple harmonic motion in an elastic cord is given by half lambda over L, half lambda over L x squared. You can use that one there. So there also I'll do the questions when it comes. You can do in two different methods. Wherever we can do mostly by using energy equations, we could be able to use Newton's second law also. So here first method I used energy equation. Second method for the B part, I'm using the Newton's second law. The same answer is obtained. Okay, question number 4, again it's based on center of mass. The same principle we'll use, x bar, what I explained earlier. The second question, I think I already explained. First question, yeah, explained about the center of mass in the first question. The same principle I'm going to use it again for this one. So it says it's actually a uniform rigid solid cone C that has diameter 6a and the height 8a. So from that cone, a portion, upper part, which has a height of 4a is removed. That's all. The question says from the initial cone, this one, which has height 8a and the diameter 6a, it's a solid cone. The upper part, which has height 4a is removed. So this is the remainder of balance after removing. The question is, find the center of mass of this solid, which is named as S. Yeah, find the center of mass of this solid after removing this portion. It's called S. Its center of mass from O, from the base. We need to find it. So anyway, we need to find this. We had to use the same principle. Sigma mxi over sigma mi is equal to x bar, the center of mass distance from the same point as we are measuring for the other center of masses also. Okay, so if I want to use the same principle, first I need to find the mass of the given cone, solid cone, mass of the portion which is removed, then I need to find the mass of the remaining portion S. Also, I should know the center of mass of this cone that is given in the data sheet. So for a cone, the center of mass is given in the data booklet. So I need to find the center of mass of this portion. So the center of mass of the of a cone is given as for a solid cone of radius r and height h and radius r. You must know the volume is given by 1/3 pi r squared h. That's the volume. You must know that. Then in the booklet is given the center of mass of this cone from the base or from the bottom part. The center of mass, the distance is given as 1/4 of the height h. So we are going to use these ideas in these questions. Then we are going to use the principle or the mathematical relationship what we use for finding the center of mass. Okay, so in this way we'll find the mass of the cone first. So we can take the density of the material rho, it's no problem, that will get cancelled finally. So we are going to find the mass. So the volume of this cone, we know that V is equal to 1/3 pi r squared h is the general format. So that is 1/3 pi r squared. So the radius is 3a, the diameter is 6a, means 3a all things squared into h is 8a. So that's the volume of the given cone. So that will be when you solve, anyway we will finally solve it, that will become 24 pi a cube is the volume. So the mass of the whole stone, the cone, m is going to be multiplied by density 24 pi a cube rho. Don't worry about the rho, that will get cancelled. Sometimes maths books, they don't use rho, they take it as 1. It's okay, no problem. Okay, so that is the first we must know for the mass of the given cone. Okay, so next, what could be the mass of the removed cone? So the 4a, if I consider this one as like this, so this is 4a, this is 4a, this is the portion removed. So I need to find the mass of this removed portion, that is 4a. For that I must know the radius of it, the radius of the removed cone. Okay, so how can I find the radius? I can use similar triangles. So O is the center, connect a vertical line from here, draw a line from here, okay, so when I consider this right angle triangle, this radius we know that is 3a over r1 is equal to, this is 8a over 4a. From that this radius r1 I can find, r1 is the radius of the removed cone. Also they cut a portion inside also, you can see the question. So they remove the upper part, then inside also a portion is cut and removed, which is similar to the portion removed from the upper part, same portion is removed from the bottom part. So the remaining S means this portion also won't be there. Anyway, that's not an issue, you can read the question and find out. We had to find the center of mass of that S, right. So R1 is the radius of the base of the portion removed from the upper part. So we can use the similar triangle. So when we consider these right angle triangles, so this radius, that is this radius is 3a over r1, 3a over r1, because these are the right angle triangles. You can see the right angle triangles, and this is the right angle triangle. So they are similar triangles. So 3a over r1 is equal to 8a over 4a. So r1 is equal to 3a by 2. So that's the radius of the cone which is removed from the upper part of the given cone. We'll find the mass of that cone. We'll call it as m1. m1 is equal to mass of the removed cone from the upper part. m1 is equal to, we know the volume into density. Volume means pi r squared h. So 1/3 pi r squared h, 1/3 pi r squared is 3a by 2 all things squared into height is 4a into rho. So that will be equal to, solve it, yeah, you will get pi a cube rho, pi a cube rho, right. Now the same mass is removed from the balance. After removing the upper part, you will get the portion, this one. From that inside also the same identical cone is removed. So the cone removed from the bottom part, that if I say M2, that's going to be the same pi a cube rho, because this cone and this cone are identical cones, so that also pi a cube. So mass of the S, that is the mass of the S, the remaining portion, mass of S S is the remaining portion of from this cone after removing upper part and from the inner part. So that is going to be the initial mass 24 pi a cube, 24 pi a cube rho minus this plus this m1 plus m2. So that is m minus m1 plus m2. So that's going to be pi a cube rho plus pi a cube rho. So you will get the mass of it will be 18 pi a cube rho. Is it correct? 24 pi a cube. Yeah, that will be okay, that's a small mistake. This is 3 pi a cube rho. 3 pi. So the M2 also 3 pi a cube rho. So there will be 3 pi a cube rho. So minus 3 pi a cube rho plus 3 pi a cube rho. So the mass of S, that will be 18 pi a cube rho. Okay, that's the mass of the S remaining portion. We need to find the center of mass of that one. Okay, so we know that center of mass, how to find this idea. I'm going to use this one before finding the center of mass of S. The idea, I'm going to find the center of mass of S after removing upper portion of the cone, and inside the remaining portion is this one. So this is the S. I need to find the center of mass of S. This is S. I need to find the center of mass of S. The idea, I'm going to use the same thing. Sigma mi xi over sigma mi is the center of mass. So that means x bar is equal to sigma mi xi over sigma mi with the center of mass. If I cross multiply, that is x bar into sigma mi. That's the summation of the total mass is equal to sigma, that is summation of mi xi, mass into center of mass. That's idea. Okay, so here what's the idea I'm going to use for that? We know the center of mass of the whole, the given object, given cone, I know that will be at a distance of 1/4 of height from the base, that is for this one. So I can imagine the given cone is equal to, the mass of the given cone is equal to, or I can imagine the given cone is made of the S plus this cone and this cone. So when all bound together, we will get the given cone S. So that means I can use this principle, that is x bar into the center of mass of this one. I know that center of mass of this one, I know that 1/4 of 80. So that is 1/4 of 80 into the total mass of it, sigma mi, that is the total mass of the system. So the total mass of it, this one, the whole thing, that is 24 pi a cube. I write it again, I'm just explaining. 24 pi a cube is equal to the mass of the S, we know that 18 pi a cube rho, the rho we can remove it, I'll put a rho here, into x bar, I need to find it, plus mass of the inner part, we know that that is 3 pi a cube rho, and its center of mass from this point is 1/4 of this height, means from here we know that that is 1/4 of this, means 3/4 of 4a. So that we have to write it here, plus then center of mass of this one, the upper portion from base is 1/4 of h. From here we can find it. So this mass into the center distance of the center of mass from O, we'll write it here. So when you add all these things, that will satisfy the given mass of the given cone times distance of the center of mass from this one. So anyway, I'm going to use the basic idea, this one again. Okay, so I'm going to use the same principle again, that is x bar into the total mass is equal to sigma mi xi, or the summation of mi xi. So here the three portions will be there: s, then the cone which is removed from the inner part, and the cone which is removed from the upper part. Those will come on the right side. Okay, x bar is the center of mass of the given cone, and m is the mass of the given cone, that is 24 pi a cube, 24 pi a cube rho into 1/4 of h. For a cone, its center of mass, solid cone, the center of mass will be from the base 1/4 of the height. So that will be 1/4 of the height is 8a is equal to, right, for the solid S, the mass is 18 pi a cube rho into the distance I need to find, the center of mass from O. That's the question, they have to find it from the O, that is x. We'll find that x. Plus, for the cone which is removed from inner portion, its mass is 3 pi a cube rho, 3 pi a cube rho into its center of mass from O I need, right? Because I'm finding everything, all the solid objects for the distance of the center of mass from the base O. So its center of mass from here, this height is 4a. So center of mass from here is 1/4 of 4a. 1/4 of 4a means a. From here, the center of mass will be at a, means from here it will be 3a. So into 3a. That is, again I'm telling, for this cone which is removed from the inner portion, the center of mass will be 1/4 of the height. Height is 4a for this cone. So 1/4 of 4a is a, means from here 4a minus a, 3a. Plus, for this cone, its mass also 3 pi a cube, 3 pi a cube rho, and its center of mass from the base of that cone 1/4 of a. So this is height is 4a, 1/4 of a of 4a is a plus 4a, 5a into 5a. Or if you want, I can put it like this. This one as 4a minus 1/4 of a. Anyway, that's 3a. This 3a, how I got it? 4a minus 1/4 of a. That is the 3a. This how I got it? This is 1/4 of a plus 4a. That is 4a plus 1/4 of a. 1/4 of 4a. That is 5a. Okay, so we have found everything. All the a, everything will get cancelled. So finally, here you know that rho will get cancelled. Pi will get cancelled. Okay, anyway, just lot of numbers, you have to solve it carefully. So here a cube into a to the power 4. Here you will get answer in a. Here again a to the power 4. Here a to the power 4. Solve it and find the value of x. Carefully you have to solve it and find the value of x. So on the left side, if you solve, you will get 48 a to the power 4. That is 24, here 4, this will become 4, 8, 2 into 24, 48. All the pi got cancelled, rho got cancelled, so a to the power 3 into a to the power 4. We got 48 a to the power 4 on the left side. So here that will remain as 18, pi got cancelled, rho got cancelled, 18 a cube x. I need to find the x. Then here if you solve it, 3 into 3, 9, 8 to the power 4, 9, 8 to the power 4, plus here 5 into 3, 15, 8 to the power 4. Okay, so we'll continue. This is 18 a cube x. I'll make it as a subject. Equal 48 a to the power 4 minus 9 a to the power 4 plus 15, 24 a to the power 4. Okay, so that will be 24 a to the power 4 divided by 18 a cube. X will be 24 a to the power 4 over 18 a cube. So you will get a, this is 6, 3, so that means 4 by 3, is it 4 by 3 or 4a by 3. That's the final answer. That's the distance of the center of mass of S from O. Principle is the same, sigma m by xio, sigma m by equal to x bar. Okay, so the B part of that same question, it says the point A lies on the circumference of the base of S. S is the remaining portion. So this is A at this point, this is named A and this is named B. Okay, and point B lies on the circumference of the top of S. The point O, A and B all lie, O, A, B, O, A, B all lie in the same vertical plane as shown in figure 5. Okay, that's, they are giving a diagram. The solid S is freely suspended from the point B. From here they are hanging it freely suspended from the point B and hangs in equilibrium. Find the size of the angle that AB, size of the angle that AB makes with the downward vertical. Okay, so here the idea again what you learned in IGCSE. So if you have a non-uniform object, something like this, maybe its center of mass, if it is here, this is the center of mass G, and if you hang it from here, what will happen? When you hang it from here, what will happen? So this will rotate until this, below this point, the center of mass G comes. For example, if you hang it from here, the string is hung vertically like this, is it? So the weight also will act along the same line of action of the tension of the string, because then only the upward force equal to downward force and there is no turning effect further. The turn effect will become equal to 0. So this will rotate until, difficult to draw, but anyway you learn that IGCSE, the G will come below the point P. So it will rotate such that, little bit difficult to draw, but I'll try. So it comes like this, like this. So this is the point P. So the G will be somewhere here. So the line from where you are hanging, that's an important conclusion I should say. The point from where you are hanging and the center of mass will be along the same vertical line. Along the same vertical line. Okay, so that's the idea we should know. So here they are saying, we already found the center of mass of this solid S after we removed. So there's a portion removed, I didn't draw it. So the center of mass of this height is 4a, we know that this is 4a. We know the center of mass from O is at 4 by 3a. 4 by 3a, so it could be somewhere here. So the center of mass is somewhere here, name it G. The center of mass is somewhere here. So they are hanging this S from point B, means the line BG will become vertical. So I don't need to draw like this again, not necessary. I can imagine, by imagine I can say the line BG will be in vertical. So the question is, Find the size of the angle that AB, size of the angle that AB, this side AB makes with the downward vertical. So the downward vertical is going to be BG. You understand? When you hang it from B, BG, the line BG will be vertical. So I need to find the angle of AB with the vertical. Means I need to find the angle between AB and the BG. That's the answer. That's the thing I need to find it. Okay. So I need to find the angle between AB and BG. So it's purely geometry. So I need to find the angle between AB and BG. That angle, let that angle be theta. We'll name that angle. What I am going to find, let it be theta. So AB and BG, that angles, I can put a solid line even. So that angle, let it be theta. I need to find this theta. If I find it, that will be the answer. So we know the length OG, that is 4 by 3A. OG is 4 by 3A. This height is 4 by 3A. 4A by 3. Already we found it in the previous part. Okay, so how can we find this angle theta? Okay, this is the idea. Now, if I extend this line, if I extend the AB, this is 4A. If I extend this line, it will meet at the initial vertex point here. So, if I extend it, it will meet somewhere like this. So, this height we know 4A. If I find this angle, the whole angle, how can I find it? We know this height 4A, we know this radius, already found it in the previous part, that is I think 3 by 2A. Yes, we found it 3 by 2A. This radius we found it 3 by 2A. So we know this side length, we know this height, that is 4A. So name this one alpha 1. So if I use this alpha 1, if I find the alpha 1, then that alpha 1 is equal to tan inverse. When I consider this right angle triangle, tan inverse opposite, that is 4A over R1. R1 is 3 by 2A. So find the alpha 1 first. That is 69.4 degree. You understand? In this triangle, so I'm considering we name this O, so name P, this is Q. So in the triangle BPQ, in this right angle triangle, tan alpha 1 is equal to opposite PB. PB is equal to 4A because we know initially the height was 8A. This is 4A, means this is 4A. This height is 4A. 4A over R1, this radius we found it in the first part, that is 3 by 2A. So solve it, you'll get 69.4 degree. Okay, so I know the alpha 1. Right. Can we find this angle? Is it possible to find this angle alpha 2 when by considering the triangle BPG? Is it possible to find this angle alpha 2? In the triangle BPG, is it possible to find the angle alpha 2? Yes, we know PG how much? This height is 4A, this height is 4A by 3. So PG, we can find it. So the length PG, so length PG is equal to 4A minus 4A by 3. That's going to be 8A over 3. Right, in the triangle BPG, the right angle triangle BPG, tan alpha 2 is equal to PG over PG over R1. This rate is already found in BP. BP is R1. BP equal 3 by 2 A. We already found it in the first part. Okay, substitute and find the tan alpha 2. Tan alpha 2 is equal to PG. So that is going to be 8A over 3 over 3 by 2A. So that will be 16A. Oh, you can solve it. Yeah, that is 16 over 9. So that is alpha 2. So alpha 2, find it. So the alpha 2 will be equal to 60.6 degree. Check it, 60.6 degree, that is alpha 2. Okay, when you consider this line, the total angle is 180. So that means theta we need to find it. That's the angle of AB with vertical. Anyway, when it hangs from BG will be vertical. So we know that theta plus alpha 1 plus alpha 2 equal 180 degree. So theta plus alpha 1 we found it 69.4 plus alpha 2 60.6 equal 180. So find the theta. That's the answer. You will get 50 degree. That's the final answer. That's the angle of AB with vertical line. The idea here, I don't need to draw it again. I know the line BG is going to be vertical. The question is with vertical, what will be the angle of AB? Okay, so the question number 5 based on simple harmonic motion. So there the question says that particle P is attached to two different length of strings AC, AC, and this is B. Sorry, not A. This is B, AC, and BC. They have different lengths. The length of AC and BC, they have different lengths, and they have different modulus of elasticity. After they are attached to the particle P, the total length of AB becomes 10A. So they are the length of AC is given as 2A, the natural length, and its modulus of elasticity is given as 2mg. For this one, the initial length is given as 4A, and its modulus of elasticity is given as 6mg. The question is, find the extension of each elastic strings after they attach like this. Okay, so we know the equations related to simple harmonic motion. First, you should know, it's given in the booklet. First, you should know the E squared equal, first you should know x double dot equal minus omega squared x. That's the thing we should show something is moving in simple harmonic motion. X double dot, that is the second derivative of x, or dv over dt, that is x double dot. Directly proportional x we have to show with a negative sign. Then the next equation is V squared equal omega squared into a squared minus x squared. Careful here, a indicates amplitude. In physics, a indicates acceleration, but in simple harmonic motion M3, symbol a indicates amplitude. Also, we should know that tension is given by lambda over L into x, and the elastic potential energy stored in the stretched material given by half lambda over L x squared. Those are the things we are going to use. Mostly we use in the questions related to simple harmonic motion. Okay, so here the particle P is at rest. So if the particle P is at rest, what are the forces acting on the particle P we must know. So if I draw the forces acting on particle P, they are saying the particle P has mass m given in the question. So if the mass of the particle is m, one with that's giving particle m, so then its weight will be 2 mg, that will act vertically downwards. 2 mg will act vertically downwards. The string which attached from A, the string or the elastic cord AP is stretched, so there will be tension that elastic rope or elastic string will pull the particle P down by exerting a tension T2. Same way, this string also stretched, so there will be elastic tension that is going to be T1. These are the three forces acting on the particle P, and we know the particle P is at rest, means the resultant force acting on it must be equal to 0. So the extension of each strings we don't know, we don't need to find. We will say the extension of this string is x2, the extension of this string is x1. Okay, so we know. So now we are going to write the tensions in terms of extension. So T1 is equal, we know T equal lambda L over X, lambda over L into X. That's the equation we normally use. So T1, which is upward direction, T1 is going to be lambda 1 over L1 into X1. So lambda 1 is given, that is the string attached from B to P, that is given as 6 mg, the modulus of elasticity, 6 mg. L1 is given as 4a, x1. Same way, x2 is equal to lambda 2 over L2 into x2. So that is, x2 is the extension of this one. Lambda 2 is given as 2 mg over L2 is given as 2a, x2. So that will be mg over a, x2. 2 and 2 will get cancelled. Okay, so we know that since the particle P is at rest, the resultant force must be equal to 0. So since P is at rest, we can say T1 minus T2 minus mg, not 2 mg, mg. The weight is mg. Yeah, the weight of the particle is that's mg given, particle of mass m. Yeah, minus mg, we'll write upward direction, or we can write downward. Either way we can write, no problem. So we'll write either way, T1 minus T2 minus mg equal to 0. Instead of T1, we can substitute this one, 6 mg over 4a x1 minus 2 mg over 2a, that is mg over a, x2 minus mg equal to 0. Okay, so all the mg's will get cancelled. So you will get 2 over 3, and all the mg's will get cancelled, and you can multiply it by a. You will get, finally when you solve it, you will get okay, right, next step also mg's will get cancelled, bring the mg to the right, so there will be 1 and multiply by 4a. So you will get it like 3 by 2 x1 minus x2 over a equal 1. Okay, so multiply the whole equation by 2a, you will get 3x1 minus 2x2 equal 2a. Equation 1. Okay, so to solve and find x1 and x2, we need one more equation. So this, we got this equation based on they are at rest. Now the second one we can find in terms of x1, x2. So we know their initial length, that is 4a, the other one is 2a. So 4a plus 2a is 6a. But the distance between A and B is 10a. So natural length of the two strings are 4a and 4a and 2a. So the total length, natural length is 6a. In the diagram, that is 10a. So 10a minus 6a is 4a. So that means the 4a is equal to sum of the extension of the two strings. Okay, so we know that the sum of the extensions x1 plus x2, x1 is the extension of the upper string, elastic string, and the x2 is the extension of the lower string. So x1 plus x2 equal, the total length is 10a. From that, subtract the sum of the natural lengths of both strings, that is 4a plus 2a. So that is going to be 4a, second equation. Okay, now we have two equations. The question is find the show that each string has the same extension 2a. Okay, we'll see. We'll solve it and find x1 and x2. Okay, so this is the first equation. This is the second equation. Simultaneous equation. We need to solve it. Okay, you know how to solve. You can use the calculators, but with a you can't. So we'll solve manually. This is 2x1. 2x1 plus 2x2 equal 8a, equation 3. Okay, so add 3 plus 1, 1 plus 3 the equations. So 3x1 plus 2x1, 5x1 minus 2x2 plus 2x2 will get cancelled is equal to 2a plus 8a, 10a. So x1 equal 2a. Right, we found it. Extension of one string, and substitute it in this one. From the second equation, x2 is equal to 4a minus 2a equal to a. So that's what they asked to show. We showed it. Okay. Okay, so the B part, the particle P is now pulled down vertically so that it is a distance A below C and then released from rest. Okay, careful. So in terms of simple harmonic motion. So now to make or to perform simple harmonic motion, we should pull this particle P either up or down and release it, then it will oscillate. Now during the oscillation, this position where the particle was at rest will be the equilibrium position, because the equilibrium position in simple harmonic motion means the point at which the resultant force becomes equal to 0. At this position C, the resultant force acting on the particle is at 0. We took that. That's the way we showed the extension of this string and this string, both each of them are 2a. Right, now from this position we pull it through a distance C downwards and release means during the following oscillation, the amplitude will be equal to C. If we pull it through a distance of 0.5a and release, that will be 0.5a will be the amplitude of the following simple harmonic motion. So whatever the distance we pull from the equilibrium position and release, that distance or that magnitude will become amplitude during the oscillation, simple harmonic motion. So they asked to show the first B part, show that the subsequent motion P performs simple harmonic motion. So to show that, we have to show x double dot equal minus a constant, that will be the omega square into x. So here when we are doing it, we know that it's pulled through a distance C from distance A from point C, that's going to be the amplitude, but we'll say it's pulled downwards through x. We'll keep it as a variable because we want to show it as a simple harmonic motion with a specific value that is the displacement equal A, that's going to be the amplitude. We can't show that. We need a equation x double dot equal minus omega squared x. The minus omega squared means there must be a number, maybe something like x double dot equal 4 by 3 x minus 4 by 3 x, something like that. We need a number, that number will be the omega square. So we have to show in terms of a variable x. So rather than considering the distance pulled down is A, I'll take it as x as a variable to show it as a simple harmonic motion. So if the particle is pulled downwards through x, now the particle has come to this position now. So this is the point A, this is the point B. We'll draw the line again. Okay, so this is the point P, this is the C, equilibrium position. This is X, pull down. I put arrow downwards, pull down through X. From the equilibrium position downwards through X, it's pulled. So there, the extension of this string now becomes that I can name it X1 again, no problem. Earlier it was 2A, now 2A plus X. This extension, it was earlier 2A, now it's reduced by X, so that is, this is X2 is equal to 2A minus X for the lower string AP. Now these are the extensions of upper string, upper elastic string and the lower elastic string. Okay, so we know the forces acting on P. The resultant force is not equal to 0 after you pull it P from C to a point. We can call this point N or something like that, Q. When you pull the particle P from C to Q, the particle won't be at rest because it's going to oscillate. It's going to move from P further. So the resultant force acting on at P at the point Q is not equal to 0, right? But the resultant force acting on P at C is equal to 0. So when we consider the resultant force acting on P, we will think about the forces acting on P. So if I draw the P, so there will be tension T1, I'll name it as T1, that is upward direction, that is lambda O1 over L1 into 2A plus X. This is T2, that is equal to lambda 2 over L2 into 2A minus X. I show that 2A minus X. Then also there will be weight mg. Okay, so when we do simple harmonic motion, we had to show that pattern x double dot equal minus omega squared x. For that, we need a direction because its acceleration is a vector. We take the direction along the direction of x taken positive. So we'll write the resultant force acting on it along the direction of x. So that means from C it's pulled downwards. So we'll consider downward direction F equal MA, but instead of A we write x double dot, mx double dot. What are the forces acting? So downward direction is taken positive. We need to define a direction. So careful, then we don't make any mistake. Along the direction of x, we take it positive. So downward direction, it's pulled from C downward. So that direction taken positive. So any force that is acting downward will be taken positive. Any force that is acting upward will be taken as negative. So that means T2 plus mg minus T1 equal to mx double dot. T2, what is T2? Lambda 2 over L2, 2a minus x, 2a minus x, is it? Yeah, plus mg minus T1, what is it? Lambda 1 over L1, 2a plus x equal mx double dot. Okay, then substitute the value of lambda 2 L2. Lambda 2 we know that that's given as lambda 2 is 2 mg over 2a, 2 mg over 2a into 2a minus x plus mg minus lambda 1 is given as 6 mg over L2, that is L1. L1 is 4a, 2a plus x equal mx double dot. Okay, solve it. 2 and 2 will get cancelled when you multiply inside. Here, this 2 will get cancelled. A, then it will be 2 mg minus when you multiply 2 and 2 got cancelled. Mgx over a. Mgx over a plus mg, then here 3 by 2, 2 and when you divide up and down by 2, so 3 mg, here 2a, this 2a get cancelled, so 3 mg minus 3 mg, so then here 3 mg over 2a, 3 mgx minus 3 mgx over 2a equal mx double dot. Okay, so here 2 mg plus 1 mg, 3 mg minus 3 mg, they'll get cancelled. So 2 mg minus 3 mg got cancelled. Minus mgx over a minus mgx over 2a. So when you take 2a as an LCM, that will be minus 2 mgx over 2a minus mgx over 2a. Then it's going to be minus 3 mgx over 2a minus 3 mgx over 2a. Here there will be I think 3 is missing. Yeah, yes, there's a mistake. 3 mg over 2a, 3 mg into x, 3 mgx. So yeah, there's a mistake. 3 mgx. Careful, there could be mistakes like this. Lot of numbers. Yeah, 3 mgx over 2a. So that's going to be 2a. If I take it LCM, 5 mgx over 2a. I'll continue here. 5 mgx over 2a minus, there will be minus, is it? 2 mg plus mg, 3 mg, 3 mg get cancelled. LCM 2a, so 2 mgx over 2a minus 3 mgx over 2a minus 5 mgx over 2a is equal to mx double dot. M get cancelled, so that means minus 5g over 2a into x equal x double dot. Rearrange it. X double dot equal minus 5g over 2a x. So it's in the form of simple harmonic motion. X double dot equal minus omega squared x, because g is a constant, a is a constant. Therefore, x double dot is directly proportional to minus x. Therefore, it is simple harmonic motion. And omega squared is equal to 5g over 2a. So along the direction of x, take it positive. Nothing will go wrong. So this answer for the B part. Now C part, they are saying, the question says, now the C part, find in terms of A and G the speed of T when it is a distance 7 by 2A above A. 7 by 2A above A, find the speed. Okay, so that is actually, we need to find the displacement. We'll find it. Okay, so part C of question number 5. Find in terms of A and G the speed of particle P when it is a distance 7 by 2A above A. Right. So this we can do in two different ways. One, we can use the equation v squared equal omega squared a squared minus x squared. We can use that directly and find the speed, or we can use Newton's second law by finding the forces acting on it. Anyway, I'll do the both methods. Energy equation also we can use, loss in elastic potential energy, gain in GP, those things we can do, but it will be more complicated, so I don't want to do it. But we can do that way also, nothing will go wrong. Those who are interested, you can try that way also by using energy equations. Okay, so here the particle, we already know that D part they showed is pulled through distance A from C, means amplitude will be A. Simple A is the amplitude, and it's going to perform simple harmonic motion. I found the angular omega squared also, I found it. I think 5g over something like that. I think it's, yeah, 5g over 2a. I found that also. Right, now if the particle, when the particle is at a distance of 7 by 2a above a, means 7 by 2a above a, this distance is 7a by 2. You know, in this equation v squared equal omega squared a squared minus x squared, the x is measured from the equilibrium position. If you are substituting equilibrium position, from that only I can measure the x. X is the displacement. So this is the equilibrium position I told when the particle was at rest. This is the point at which it remained at rest. So I need to find the displacement when the particle is at a distance of 7 by 2a from A, means I need to find its displacement, this portion, how much will it be? Okay, so what could be the length of AC? What's the length of AC? Length AC is equal to, we know the extension of the lower elastic string, that is 2A. Its natural length also we know that 2A. So the natural length plus extension of the lower string is AC, that is 2A plus 2A, that is equal to 4A. So the length AC is equal to 4A. But the particle P is at 7A by 2, means the displacement X is equal to 4A minus 7A by 2. That will be A by 2. So I need to find the speed when the displacement is A by 2. I know the amplitude is A because the particle is pulled from C through a distance A and release. I told that if you pull an oscillator through a distance A or distance 2 meter or whatever it is, from the equilibrium position through what distance you pull it and leave it, that will be the amplitude of the following oscillation, simple harmonic motion. So the amplitude we know A. So I need to find the V when the displacement is A by 2. So substitute it. So V squared, this is the easiest method. V squared equal omega squared into A squared minus X squared. Omega squared phi G over phi G over 2A into A squared. Amplitude is A squared. X squared. X is A by 2 squared. Solve it. So that's going to be phi G over 2A squared minus A squared by 4. So that will be 3A squared by 4. So phi G over 2A into 3A squared over 4. So 2A, 3A squared, A will get cancelled. So 2, that is going to be 8. So that means B squared is going to be 15 AG over 8. So the speed will be square root of 15 AG over 8. This is the speed when it is at a distance of 7A by 2 from the lowest point A. Careful, in this equation X must be measured from the equilibrium position. So this is the method 1 for part C. Okay, so there is method 2. There we can use directly from calculus, from x double dot equal minus omega squared x. I can use it, and from that I can proceed further. Okay, so part C, method 2, for that also I need the displacement, because I told in simple harmonic motion all the displacement are measured from the equilibrium position. So same as earlier, the displacement is A by 2. But here I am not going to use the equation B squared equal omega squared A squared minus X squared. I am not going to use. I am going to use the basic equation x double dot equal minus omega squared x. I am going to use that equation. We know the minus omega squared is phi g. That is this I can write dv over dt. That's acceleration, minus phi g over 2a. I think, yeah, phi g over 2a x. Okay, so this could be written as dv over dt, could be written as dv over dx, dx over dt. I earlier also wrote dv over dt is equal to dv over dx into dx over dt. Dx over dt is v, so that will be, this is v dv over dx. It's given in the equation, that formula book also. Right, so this we can write v dv over dx equal minus phi g over 2a x. Okay, we need to get a relationship between x and v, means only thing we need to do integration. So that is integral v dv equal minus phi g over 2a constant integral x dx. Okay, how are you going to put the limit? When the x is equal to a, that is the amplitude, when the particle is released from the maximum displacement, but is a, that's amplitude. So when x equal a, the speed was 0 because it starts to move from rest. So at the extreme positions during simple harmonic motion, speed becomes 0. When the x becomes a by 2, that's a question, a by 2, the speed I need to find it. So I need to find the v. That's all. So now solve it and substitute. Okay, so we need to integrate it. So that will be, this will be v squared by 2. The limits 0 to v equal minus 5g over 2a x squared by 2, that is a to a by 2. So that's going to be v squared by 2 minus 0 equal minus 5g over 2a. Here x squared means a squared by 2. Is it a squared by 2 means it's going to be a squared over 4. A squared over 4. This 2 I can take it out, so that will be 4a. A squared over 4 minus, so I'll put this 2 as like this, x squared, sorry, x squared by 2, that 2 I took it out, so 4a, so x squared means a squared by 4 minus a squared. So that will be v squared equal 5g over 2a, 4a to 2a. Here it's going to be a squared minus goes in a squared minus a squared by 4. So that will be 4a squared minus a squared, 3a squared. 3a squared into 5g, 15a squared g over 2a. Sorry, 2a into 4, 8a. So this is a squared. A squared a get cancelled. So 15ag over 8 is v squared. So v is going to be square root of 15ag over 8. Earlier also we got the same answer. So either method we can follow, but using the equation v squared equal omega squared a squared minus z is simple. Yeah. Okay, question number 6. I think I missed the question number 3. I think the circular motion. I'll do it after discussing the question number 7 of this paper. Okay, question number 6. Even question number 3 is also based on circular motion. Question number 6 is based on circular motion. A particle of mass m is attached to one end of a light inextensible string of length 2a. So that means the radius of the circular path is going to be 2a. Right. The other end of the string is attached to a fixed point O. The particle is initially held at point A with a string taut under tension and it's thrown at a speed of 3 root ag as shown in the figure. This diagram is given in the paper. So the question is, show that the particle performs complete vertical circles. Okay, so you know what happens. You must know these things when you are doing questions related to circular motion. You should be able to identify the center of the circular path. That we know O is the center of the circular path. But if it is like a question related to a particle moves inside a hollow sphere, something like this, those questions appear. So this is the hollow sphere. This is the center of the sphere, but particle is moving on a circular path inside the sphere here. So this is not the center of the circular path, in which the center of the circular path will be this one, not this one, right? So like that you should be able to identify the center of the circular path first. Then you must be able to identify the actual forces acting on the particle. you must be able to identify the actual forces acting on the particle, right? If it is like here, there will be normal reaction and the weight. Those are the only two forces acting on the particle if the particle is moving inside a hollow sphere, but that is not the question now. Just I took it as an example. But when we consider this situation, how many forces are acting on the particle? There are two forces, one is the weight and the other one is the tension. You should be able to identify the actual forces acting on the particle. Then you must know to find the resultant force towards the center of the circular path. Careful, you must be able to resolve all the forces acting on the particle such that the resultant force towards the center of the circular path, that is the centripetal force. Centripetal force is given by F equal mr omega squared or F equal mv squared over r. You must know this equation, those are given in the booklet. So this is the resultant force acting towards the center of the circular path, that is called centripetal force, right? Then you should know when a particle moves on a circular path, the particle has intention of moving away from the center, that is called centrifugal effect. So due to centrifugal effect, the tension exists. Why there is tension exists? Due to the centrifugal effect. When you make a particle to move on a circular path, the particle will have intention of moving away from the center. Due to that reason, there will be tension here. Same way, for example, you can take a small bucket filled with water and rotate the bucket in a vertical plane. This is the bucket filled with water. So by holding it here, the handle, rotate the bucket on a vertical circle. Even when the bucket becomes upside down during the motion, the water won't spill out of the bucket. Normally that question appears in physics, but maths you won't get such questions. But you must know the principles. I told, even if it is a mechanics, it's based on physics principles. Only thing you get in mechanics, more mathematical approach, that's all. But principles are the same. So when you rotate in circular path, the bucket, the water inside the bucket won't spill out. The reason the water is moving on a circular path, the water has intention of moving away from the center, so it will stay inside the bucket. So these things you must know. So here the question is, in this paper, the question is, they are saying when the particle is thrown at speed initially 3 root ag at an angle 60 degree with the vertical, and the question is, show that the particle performs complete vertical circles. So we will say during the motion at any points, the tension will remain not equal to 0, or tension will be a real value, or tension is greater than 0 at any point. If you show that the string won't slack means the particle has intention of moving away from the center. I told that that's the reason for the tension. The particle has intention of moving away from the center, so the particle will try to move away. That causes tension on the string. So we will show that at any position of the motion, any position means we will take an angle theta. I'm going to do that way. At any position, the tension will be a positive real value. That means the particle will move on a circular path throughout the vertical circular orbit, right? So for that we will take like this. So it was thrown at a speed 3 root ag from a position which makes 60 degree with the vertical. So during the motion, somewhere when the particle comes to a position somewhere like this, I don't know the speed, let it be v, and then we take that makes an angle of theta with vertical. The radius is 2a. We don't know what is the angle theta, so I'm going to keep theta as a variable. So when the particle goes to the highest point, you know theta will become 180 degree, pi radians, is it? So we'll show that the minimum value of t, even during this motion, minimum value of t at any point is greater than 0. If I show, that means the particle will continue to move on circular path. Why? The tension is remaining there, non-zero value means the particle has intention of moving away from the center. So a particle has intention of moving away from the center means it's continuing the circular motion. Okay, Okay, so when it moves from the position from where it was thrown to the position, I just took an angle theta just after it was thrown. So we can use the energy equations for the motion from this point to this point. So the energy equation means loss in kinetic energy equal gain in gravitational potential energy. So gain in gravitational potential energy means we need to find the height it moved vertically upward. So that means this is the height between these two lines. This height we need to find. That's the height we are going to use for the gain in gravitational potential energy. So that we can find by using these two right angle triangles. So we find this height, that is 2a cos 60. This height from here, this height in this right angle triangle, this height will be equal to 2a cos theta. So the h is equal to 2a cos 60 minus 2a cos theta is equal to h. So h is equal to 2a cos 60 minus 2a cos theta, that is the h. So we can take it as 2a into cos 60, we know that that is root 3 by 2, half, cos 60 half minus cos theta. Okay, we'll use that later in this equation. I'm going to write the equation now, energy equation. For the motion from this point to this point, loss in kinetic energy equal to gain in gravitational potential energy. My aim, I want to show the tension at any point during the motion is not equal to 0. That means tension exists. The particle has intention of moving away from the center. That means it's following circular motion. The question is, show that the particle performs complete vertical circle. Right, okay, that's the aim now. Okay, so loss in kinetic energy equal gain in GP. Loss in kinetic energy is initial kinetic energy minus final kinetic energy, half m. This is square of this 3 root, okay, I'll write like 3 root ag holding squared minus half mv squared. That's the loss in kinetic energy. Gain in gravitational potential mgh, that is mg into h, I found it, 2a cos 60 minus 2a cos theta. So 2a I got it out, cos 60 is half, so that is 2a into half minus cos theta. So throughout the equation, the mass will get cancelled. So that will become, so if you solve this one, m will get cancelled everywhere. So it's going to be 3 squared is 9, 9ag by 2, or this 2 multiplied to here 4. Anyway, we can show that way also. So 2, if I multiply the whole equation by 2, this 2 will get cancelled, this half will get cancelled, it will become 4 here, 4a. And also square of it, this 9ag minus, so v squared, is it 9ag minus v squared is equal to, so I multiply by 2, so 4ag into half, so that will become, okay, I'll write one step, half minus 4ag cos theta. Okay, so we'll get an expression for v squared in subject. So v squared in terms of theta, v squared is equal to 9ag. This is 2ag when it comes to the left. 9ag minus 2ag is going to be 7ag plus, bring it to the left, take it to the right, plus 4ag cos theta. So that will be the general equation for v squared. Okay, so I need to think about the tension now. I told I want to show the tension. Why I found v squared? Because tension, the equation consists of v squared also, v also, right? So we'll consider that now. So now we'll consider the tension acting on the particle at this position. So if I draw the free body force diagram, that is the forces acting on the particle at this position. What are the forces acting on it? The weight will act vertically down, mg. The tension will act towards the center. Tension will act towards the center. And this angle theta with vertical tension makes theta. So with vertical tension makes a tension with vertical theta. So this is theta. So the resultant force towards the center of the circular path, I told, center of the circular path is O. So the resultant force towards the center of the circular path. Most of the students, they try to find the vertical component. No, we don't want the vertical component. We want the resultant force towards the center of the circular path. That is the centripetal force, which is given by F equal mv squared over r. Okay, so the resultant force towards the center of the circular path, these are the only two actual forces acting on the particle. So that will be T minus mg cos theta. So I want to find the criteria equation for resultant force towards the center. So center is here O. That is the resultant force equal T minus mg cos theta equal to mv squared over r. mv squared over r. That's the equation given, standard equation given in your booklet. So T is equal to mv squared over r. M, so v squared I can write this one, m into 7 ag plus 4 ag cos theta over r. The radius of the circular path is 2a over 2a plus, take this to the right side, mg cos theta, and write the, solve it and get the expression for the tension now. Okay, solve it, you will get, this will be, you know how to solve it. So you will get 7 by 2 mg plus 3 mg cos theta. Okay, that is the tension. Now you can see the tension depends on theta. Right, tension depends on theta. This is the constant. Here 3 mg constant, but cos theta depends on theta, so tension depends on theta. Okay, I got an general expression for tension in terms of theta. Now, when it moves on a circular path, the theta is going to vary. So the minimum value of T will occur when cos theta has the minimum value. Cos theta, the lowest value is -1. You know the range of cos theta from +1 to -1. So the minimum value of cos theta is -1. That occurs when theta equal 180 degree or pi radians. That means when the particle goes to the highest position here, when the particle goes to the highest position, theta will be pi radians or 180 degree. So when theta becomes 180 degree, cos theta is the minimum value, -1. Substitute and see, will I get tension negative? If I don't get, that means the particle will follow the circular path even at the highest point. Right, so we'll find the T minimum equal 7 by 2 mg plus mg cos 180, cos 180, I'll write that way, plus 3 mg cos 180 degree, that is -1. So cos -1, so minus 3 mg. So if you solve it, 7 by 2 mg minus 3 mg, that's going to be mg by 2, which is greater than 0. So that means since the minimum value of tension is greater than 0, the particle will continue in circular path, because even at the highest point where the tension becomes minimum, which is a real value, means particle has intention of moving away from the center. Centrifugal effect is happening, so particle will continue circular path. So you had to write that, but I am not writing it. So say since T minimum is greater than 0, even at the highest point, the particle will follow circular path because tension is not equal to 0, the string is not sliding. That's the answer you should write below that. Okay, so the B part show that the particles still perform in a refined model. It is assumed that the string will break if the tension in it exceeds 7 mg. Using this refined model, B part, show that the particles still perform complete vertical circle. Complete vertical circles. Okay, so that means it's easy. I'm going to continue this. Actually, there's nothing much to do in part B since I have done a lot of work in part A. So part B, I'm going to continue this equation. If you want, you can name this equation like equation 2 or star, something like this. You can name this equation. I'm going to follow this equation for the second part. Okay, so they are saying the string breaks when the tension exceeds 7 mg. We will see what could be the maximum tension. So I got an expression for tension, how it varies with theta. So T max occurs when cos theta is maximum. Cos theta maximum means +1. That occurs theta equals 0. Theta equals 0 means when the particle, if the particle reaches highest point, we showed it. It will reach highest point, we showed it in the first part. So it's going to follow a circular path, and when it comes back to the lowest position, theta will be equal to 0. There the tension will be the maximum because cos theta is the +1 when theta becomes 0. So we will find what could be the maximum tension. If it is less than 7 mg, good, it won't break, so it will follow circular path. That's the thing I'm going to do for second part. So I'll raise the upper part of it. Okay, so B part I'm using this equation. So from the equation star or whatever the you can say from equation 2 or star, whatever it is. So B part from equation 2, I'll write that equation again. I don't need to derive again because I have already done that. T is equal to 7 by 2 mg plus 3 mg cos theta. So T max. Maximum T max is equal to 7 by 2 mg plus 3 mg cos 0. Cos 0 is +1. So theta varies, that decides the value of t. So maximum value of cos theta is +1, that occurs when theta equals 0. So that is going to be 7 by 2 mg plus 3 mg. So that will be 13 mg by 2. Yes, that is 13 mg by 2. That is 6.5 mg. 13 by 2 is 6.5, which is less than 7 mg. So 13 by 2 means 6.5, which is less than 7 means tension maximum never exceeds 7 mg. You are right at the bottom. Since the maximum tension at the lowest point never exceeds 7 mg, therefore without breaking the string, it will follow vertical circle. Okay, question number 7 again on simple harmonic motion. A particle P of mass 0.5 kilogram is attached to one end of a light elastic string of natural length 2 meters. Modulus of elasticity 3 Newton. The other end of the string is attached to a fixed point O on a rough plane. The plane is inclined at angle theta. The sine theta is given 2 by 7, so we should be able to find the cos theta and tan theta. I'll show how to find, you know that anyway. The coefficient of friction between P and plane is mu is given √5 by 5, and the mass is given lambda, or the given data. I wrote it here. The question is, the particle P is initially at rest at point O. So the string, one end of the string is attached to O, other end is attached to the particle P of mass 0.5 kilogram. The particle is kept at the point where the free end is attached on the slope, right? As shown in figure, the particle P then receives an impulse of magnitude 4 Newton second. Impulse, you know, impulse means I equal Ft, which is equal to change in momentum. By using mv minus mu, we can find the speed. We are going to use that. 4 Newton second directed up a line of greater slope of the plane. So there's an impulse provided to the particle along the slope upwards. The particle P moves up the plane and comes to rest at the point A. So when it comes to point A, it becomes rest. Find the extension of the elastic string when P is at A. So we need to find the distance OA. Right? Natural length we know 2 meters. Find the extension of the elastic string when P is at A. That's a question we need to answer now. Okay, so here sine theta is 2 by 7 means cos theta. How to find it? You know that, O level math. This is theta, so sine theta means opposite over, this is 7. So this length, the right angle triangle, 49 Pythagoras theorem, 49 minus 4, that is 45. Square root of 45 means square root of 45, 3 root 5, is it? That's the length of this side. So cos theta will be 3 root 5 over 7. So cos theta, I'll write it. So cos theta will be equal to 3 root 5 over 7. We need that during our calculation. Right, okay, now we should be able to identify what are the forces acting on the particle. So before that, you should be able to find the component. You should be able to write the component of the weight along the slope and perpendicular to the slope, because we need the component of the weight along the slope when we are considering the motion, because that component of the weight is going to oppose the motion. So we should be able to write that one. Also, we need to find the component of the weight perpendicular to the slope, because the normal reaction will be equal to component of the weight perpendicular to the force. So I show that how to find these two components. Anyway, if an object is kept on a slope like this, so its weight will act vertically downwards. This is the weight, mg, angle theta. So we need to find the component of the weight along the slope and perpendicular to the slope. So this is 90 degree. So this angle is 90 minus theta. So we need to resolve this weight along the slope, means mg cos 90 minus theta. Mg cos 90 minus theta. You know that cos 90 minus theta is sin theta. So mg sin theta is the component of the weight that is going to oppose the motion. That's the reason when you keep an object on a slope, it rolls down. Why it rolls down? Because of the component of the weight acting along the slope down, which is mg sin theta. To find the component of the weight perpendicular to the slope, that is mg sin 90 minus theta. Mg sin 90 minus theta, that is mg cos theta. Remember that also. Okay, so now I can remove this weight because I have resolved these forces into two components along the slope and perpendicular to the slope. So if the object is kept on a slope, there will be normal reaction. Normal reaction means the force that exerted perpendicular to the contact point. So the normal reaction is this way. So when object moves along the slope up or down, there is no motion perpendicular to the slope, is it? Because it's moving along the slope, not perpendicular slope. So when a particular object moves along the slope up or down, in this direction there is no motion. Therefore, r minus mg cos theta equal to 0. So the normal reaction, remember that when an object kept on a particle is kept on a slope, the normal reaction will be equal to mg cos theta. Normal reaction force will be equal to mg cos theta. So we can find the friction acting on it. We know the friction acting on the particle Fr is equal to mu r. We know that. Mu is given root 5 by 5. R mg cos theta. So we'll substitute and find the friction separately. So that is going to be root 5 over 5. Mass is given as 0.5, 9.8. Cos theta, we found it 3 root 5 over 7. Solve it. You will get the friction acting on it. So the friction you will get it, that is equal to, if you solve, 2.1 Newton. So it's easy to find that friction, that is 2.1 Newton. Easy, because when you are doing it everywhere, we don't need to write all things. So that is going to be 2.1 Newton. I found it separately because it's easy to write later anywhere. So but anyway, you should work out and show these ones. Friction is 2.1 Newton. So Fr equal mu r. Mu is given, r equal mg cos theta. I explained already why. There is no motion perpendicular to the slope, means r must be equal to mg cos theta. So r equal mg cos theta. The quantities are given, the values are given. So substitute, you will get Fr equal 2.1 Newton. Okay, so now we'll identify what are the forces acting on the particle when it moves from O to A. Okay, so we'll consider what are the forces acting on the particle. I'll draw it again, the slope and the particle. So we know that we'll draw only the forces those are acting on it. So mg sine theta is opposing the motion. Mg sine theta is one of the force that is opposing the motion. Then there is a friction Fr. I already showed it Fr, which is 2.1. Friction Fr is acting. There will be a force related to extension of the rubber. The elastic force also will act, but that will act only beyond 2 meters, because they said the length of the string is 2 meters. So until it moves 2 meters, the force due to extension, the tension on the elastic string won't act, because the string will remain slack until it moves 2 meters. Beyond it only, it's going to extend. So until that point, so I can name the point up to the point B, the string, this is 2 meters, we'll take this is 2 meters, OB is 2 meters. So until that point, the string won't be extended, so there won't be tension. Beyond it, yes, there will be tension also. So until it reaches B, there are two forces opposing the motion. Motion is upward direction. This is the direction motion. The motion is thrown upwards along the plane. So there are two forces opposing. So students normally they ask, will the particle come to rest before it reaches speed? It could happen, because depending on the initial speed that we can calculate by using the given impulse, before reaching the point B, that is before it moves 2 meters or before the string gets extended, before that the particle could come to rest because of these two opposing forces, the component of the weight and friction. Yes, that could happen. But the question is saying that find the extension of the elastic string when P is at A, means we know, because the word extension, find the extension, the word is used, means yes, we know that the particle is moving beyond B also. So we don't need to worry about it. Otherwise, in case if they ask find the length OA, we have to think about it, because it might come to rest. The A could be a point which is less than 2 meters from O. That also can happen, but here they ask find the extension, means we are sure that it's moving beyond the point B and the string is getting extended. Okay, so until B, the tension won't be there. Beyond B, there will be another force. These two forces will remain even after B, but additionally there will be one force, that is tension. Right, okay. So this question could be answered. That means we need to find the extension of the string when it reaches the point A. This could be answered in two different methods. One is by using energy equations. The other one by using F equal m x double dot Newton's second law. I'll do the both methods. So first method I'll use by using energy equations. Okay, so if I use energy equations, when it moves from O to A, I took it directly from motion O to A. What are the energy changes occur? So initially it was thrown at a particular speed. We can find it by using the given impulse. I equal delta mv minus mv. We can find it. I'm going to find it, the initial speed. So initially it has kinetic energy. So when it moves from P to A, the kinetic energy will be lost gradually, because it will be converted into other form of energies. What are the other form of energies? Because A is at a higher point than O, means its gravitational potential energy is increasing. So we need to find the increase in gravitational potential energy, means we need to find this height. We need to find this height h, that we can find it, not a big issue. That we need to find it. So gravitational potential energy is increasing. The particle is doing work against the friction, yeah. Then also beyond B, the string is going to extend, so there will be elastic potential energy will be gained. Okay, these are the three things going to happen when the particle loses the kinetic energy. Loss in kinetic energy equal to gain in gravitational potential energy plus work done against friction plus elastic potential energy gain in the elastic rubber band. Okay, those are the three things happening when the particle loses the kinetic energy. Okay, we'll find the initial speed first. So we know that impulse is equal to mv minus mu. So impulse is given 4 the mass is 0.5, v, immediately after thrown, the speed is v, or I can say immediately after thrown, the speed will be u1. It was thrown at speed u1, I'll take it as u1. So u1 minus, before the impulse is applied, the speed was 0. So u1 is going to be 8 meter per second. Okay, so we'll write the energy equations. Loss in kinetic energy equal gain in, I'll write, yeah, I'll use that portion here. Loss in kinetic energy equal gain in GPE, gravitational potential energy, plus work done against friction, plus gain in elastic potential energy. Elastic potential energy half lambda over L x squared. Okay, that happens beyond V. Okay, so loss in kinetic energy, initial kinetic energy half mu1 squared minus the final kinetic energy, because it's coming to rest at A, so that's going to be 0. So I'll substitute the values later, minus 0. That's the final kinetic energy is equal to gain in gravitational potential energy. So when it reaches point A, we know it's moving beyond B, means let the extension from B to A, let it be x. That's the question we need to find it. Let the extension be x. This is 2 meters. So gain in gravitational potential energy, we need to find this height. So this height is equal to 2 plus x sine theta. 2 plus x sine theta. Is it? H is equal to, this is 2, this is x, 2 plus x sine theta. So that is mg, h is 2 plus x sine theta. We'll substitute the values. X, we need to find it. Work done against friction. Work done against friction means friction force into distance moved. Throughout the motion, the same friction is acting. So friction force, we found it 2.1. Into distance moved, when it moves from O to A, 2 plus x. So friction force into 2 plus x. Gain in elastic potential energy, that happens beyond B. That is half lambda over L x squared. That's all. We know all the quantities except x. Substitute, you will get the x. Simple if you follow. Actually, this equation is based on physics principles. Right, okay, so we'll substitute the values. Now half into half, mass is 0.5 into u1 square. So I'm doing the first method. Second methods I'm going to use by using Newton's second law method. So I'm answering A part. So this answering A part. Right, so half into 0.5 into u1 square, that is 8 square. Mass again 0.5, 9.8 into 2 plus x sine theta, 2 by 7. Plus friction, we found it 2.1. That's easy, otherwise finding here is a bit complicated. So that's the reason I found separately. 2.1 into 2 plus x plus half. Lambda is given, 3 over L, the natural length 2, x square. Right, you know that only the unknown is x. You are going to get a quadratic equation. So solve it. Not a big issue. So you will end up with, you know how to solve, it's not an issue. So you will end up with 0.75 x squared plus 3.5 x minus 9. Carefully solve it, there are a lot of numbers. So you will end up with 0.75 x squared plus 3.5x minus 9 equals 0. Solve this quadratic equation by using your calculator in equation mode. You will get the answer for x is equal to 1.84 or either one. Both are solutions, but we don't want both because we are going to get the negative one. So minus or x is equal to minus negative 6.50. So extension cannot be negative answer, so this is not the answer. So the extension, that's all. That's a simple question, is it? Okay, so the method 2 I'm going to use the A part. Still I'm doing the A part, but the second method I'm going to use Newton's second law, F equal mx double dot or F equal ma. Okay, so there the thing is until B, the forces acting on the particle are the friction and the combo. Beyond B, there will be tension also. So that means the forces, those opposing the motion up to B, mg sine theta and the friction. Beyond B, mg sine theta, friction and the tension. So the acceleration will not be the same from O to B and B to A. So I can't use the equation, same equation for O to A. So I feel it's better to find the speed at B there until the motion from O to B, the acceleration will be a constant acceleration because frictions are constant, not depending on anything else. They are just constant forces. So we'll find the speed at B by using F equal mx double dot. So the only forces acting opposing the motion are these two forces. So we'll write up to B first. For the motion O to B, for the motion from O to B, F equal mx double dot. So the forces acting on it, I'm using it along the motion. So the forces are opposite. So that is minus mg sine theta minus fr equal to mx double dot. Is it? So minus mg sine theta. So the mass is 0.5. There's a minus sign. Minus 0.5 into 9.8 into sine theta 2 by 7 minus friction 2.1 equal 0.5 x double dot. So find the x double dot. So x double dot will be equal to minus 7 meter per second square. So along the direction of motion I'm getting negative, means we know it's going to decelerate from O to B. Then we'll use the equation along the slope from O to B, B squared equal u squared plus 2as. So u squared, we know that it was thrown at a speed of 8 meter per second, so 8 squared plus 2 into a is minus 7 into s, the distance from O to B I'm using, that is 2. So solve it, you will get V, that is the speed at B is going to be 6 meter per second. So speed at B, solve it, this one you will get 64, you will get 36, that is 64 minus 28, so that will be 36. So the V will be equal to 6 meter per second. So that's the speed at B. So speed at B is equal to 6 meter per second. Now beyond B, the deceleration or x double dot depending on x also. So now I'm going to consider motion from beyond B we'll consider. So for the motion from B to A, I'm going to use F equal mx double dot. So the forces acting on it, we are going to write again, that is minus mg sine theta minus mg sine theta. We always write this equation along the increasing x direction. So the x is increasing from B to A. So minus mg sine theta minus fr, that's a friction, minus lambda over L x equal mx double dot. Right, x double dot you know, dv over dt. So x double dot means that is dv over dt, that is dv over dx, already I wrote it several times, dx over dt, that is, this is v dv over dx. We can write that way next step. Okay, so so we'll substitute the quantities. Minus mg we know 0.5, 0.5 into 9.8 into sine theta, 2 by 7. Friction, you already found it, 2.1. Minus lambda, we know that is 3 over 3, and L is 2. X equal m, that is 0.5 again, mass is 0.5, v dv over dx. Okay, so solve it. You will get, when you solve this, minus 7, solve all these things, minus 7 minus 3x is equal to v dv over dx. Solve it, all the numbers, solve it, you'll get, finally end up with this format. Okay, so we'll integrate it. That is integral of v dv equal to minus integral of 3x plus 7 dx. Okay, so what are the quantities? X is beyond v. So when x equals 0, the speed is 6 meter per second. Is it? When x equals 0, that is at v, the speed is 6. When x equal, we need to find the value, the extension. So let it be e extension. I'll put it as e here, extension. Or I can put again x, but there, since I'm using variable, so extension e, that's a extension from B to A, extension E, the speed is going to be 0 because it's coming to rest, the question paper says. Okay, so solve it. This is going to be v squared by 2 with the limits 6 to 0 equal to minus 3x squared by 2 plus 7x, you know integration 3x squared by 2 plus 7x, 0 to e. Okay, solve it again. You'll get minus 18 is equal to minus 3e squared by 2 minus 7e. Okay, again solve it. You know that's not a big issue. If you solve it, you will get in 1.5 e squared plus 7e minus 18 equal to 0. Again, quadratic equation. Solve it by using your calculator. You will get the values for E. E is equal to 1.84 meter, or E is equal to minus 6.50 meter. But extension cannot be negative, so the answer is 1.84. We got the same answer when we use the energy equation also. So this is for B to A. I am using this equation from B to A. Okay, the part B, question number 7, show that the particle does not remain at rest at A. Okay, so they showed in the question when it reaches the point A, it comes to rest, but will it remain at rest at point A? So that's coming under Newton's first law. Object which is at rest will remain at rest unless it experiences unbalanced force. We'll see, will there be unbalanced force? Again, we need to find about the forces acting on it when it reaches the point A, right? So we'll draw the diagram. So at point A, the forces acting on it are, so there will be tension, already it has extended, we know the tension acting on it, the particle has tension. Okay, then the component of the weight that is acting downward direction, that is mg sine theta. Now friction, which direction will it act? You know, friction is a force that opposes the motion, or that opposes the intention of motion. Until it moves from O to A, the friction opposed the motion, so it acted downward direction along the slope. Now, if it remain at rest, there won't be any friction, because if it remain at rest, there won't be any friction. So if the particle comes to rest at A, whether it's going to be at rest or whether it's going to have an intention of moving down, means the friction will oppose the intention of motion. So the friction will act In case if there is an intention of motion downwards, the friction will act opposite direction. The same friction. The magnitude is constant because mu r no change. Okay, now we'll find, will there be a resultant force at A? We'll find the resultant force at A. If it is non-zero value, that means it won't remain at rest. According to Newton's first law, it will accelerate down. If it is zero, then it will remain at rest. Again, Newton's laws. Okay, so along the slope downwards, we'll find the resultant forces. F is equal to mg sine theta plus T minus F1. Okay, that is mg sine theta plus lambda over L x minus F1. Okay, we'll substitute the values and see whether it is 0. So mg 0.5, 9.8, sine theta 2/7. Lambda we know that is 3 over L, that is 2. And we found the extension, just now only found it, 1.84 I think, yeah, it's 1.84 minus friction, we already found it, 2.1. Okay, solve it. How much are you getting when you solve this? So that is 2.06 Newton, which is not equal to 0 or which is greater than 0, it's a positive value. So there's a value of resultant force along the slope down means it will accelerate according to Newton's first law. It won't remain at rest. It will accelerate from A towards O. Okay, question number 3, I missed it earlier, so I'll do it now. So this is the diagram given, this is based on circular motion. A fairground ride consists of a cabin C, so it's attached with two different light arms. They attach to a vertical support A and B. Okay, so the first part, the given data here, the lengths are 5 meter, the length of the arms, light arms, so they have no weight, 5 meter, 5 meter. AB is 8 meter. The distance from A to B is 8 meters. They are saying it. So these two lengths are same means AO will be 4 meters. So this will be from A to O, that will be 4 meters. So the C, the whatever it is, it's a cabin C or whatever particle, is moving on a horizontal circle. So the resultant force towards O. O is the center of the circular path. I told that when you are dealing with questions related to circular motion, you must identify the center of the circular path and the resultant force acting on the particle, the actual forces acting on the particle, then you should be able to resolve the resultant force towards the center. That will be the centripetal force. Centripetal force is given by F equal mv squared over r, or F equal mr omega squared. And when it moves on a circular path, the particle has intention of moving away from the center due to the centrifugal effect. So it will stretch the both arms because it has intention of moving away from the center. So both AC and BC, the arms, whether it's a string or light rods, whatever it is, they will experience stretching force, that is they will have tension. That is the question in the first part. Okay, so also given the time period is 2 seconds. So it takes 2 seconds to complete one full circular orbit, they are saying. So time period is equal to 2 seconds. Okay, so the radius of the circular path, this is the center of the circular path. Radius of the circular path, if I say that is r, I can find it by using Pythagoras theorem, r. So this is 4 because this is 5, this is 5, this is 8 means symmetrical. So this is half of it, half of AB. So r is equal to Pythagoras theorem, r squared is equal to 5 squared minus 4 squared. So r is equal to 3 meters. So that's the radius of the circular path. So I should think about the forces acting on C. I told that because we need the actual force acting on the particle, and we should be able to resolve it towards the center. So I can take this angle theta. If I take this is theta, this also theta. Is it because symmetrical? Okay, we can find the sine theta, cos theta. So the sine theta, that is equal to 4 over 5. Sorry, 4 over 5. And cos theta, that will be 3 over 5. Okay, so we'll show the forces acting on the particle. See how many forces acting. It has weight acting vertically down, that is mg. Then there is a tension due to on the upper arm, that is the question first part, that it be T1, and there is a tension along the lower arm T2. Both makes an angle theta with horizontal line. These are the three forces. So the center of the circular path somewhere here, that is O. Okay, so if it is moving on a circular path, the resultant force towards the center is the centripetal force, which is F equal mr omega squared or mv squared over r. Since the C is moving on a horizontal circle, the vertical resultant force must be equal to 0. According to Newton's first law, again Newton is coming. So according to Newton's first law, the resultant vertical force must be 0. Otherwise, there will be an acceleration upward if there is a resultant force up, or if there is a resultant force down, there will be acceleration down. Nothing is happening because it's moving on a horizontal circle. So therefore, vertical component of the forces must be equal to 0. So that means T1 sine theta minus T2 sine theta minus mg equal to 0. So we'll substitute the values. So we can take the mg to the side. So T1 into sine theta, that is 4 over 5 minus T2 4 over 5 equal, the mass is given 600 kilogram. Yes, mass is given, mass of the C is given 600 kilogram. So you take it to the right, 600 into 9.8. Okay, solve it. You know how. Then you will get a first equation T1 minus T2. Yes, I think you will get T1 minus T2 is equal to 750 into 9.8. You can solve this, but I'll keep it as it is. That's the first equation. T1 minus T2 equal to 750 into 9.8. Okay, that is based on there is no resultant force in vertical direction. I used the Newton's first law. Now, circular motion. Resultant force towards O is the centripetal force. That is T1 cos theta. If I resolve this one towards center, T1 cos theta. This, if I resolve it towards center, plus that also towards right, T2 cos theta. Mg is vertically down. So the vertical force has no horizontal component. When you resolve the vector through 90 degrees from vertical to horizontal, no component. So mg has no component towards O, that is equal to mr omega squared. You know that omega equal 2 pi over t. You must know that omega equal 2 pi over t. That's given in the data sheet. And t is given 2 seconds. The time period is given 2 seconds. So I want to substitute that also. Okay, so T1 cos theta 3 by 5 plus T2 3 by 5 equal mass 600. Radius we found it 3. Yes, 3. Omega square 2 pi over t. So 2 pi over 2 all in square. Okay, solve it. You will get T1 plus T2 equal 3000 pi square. That is the second equation. Solve it and get it. 3000 pi square, you will get it. Okay, so by using first equation, second equation, you know how to solve it. That is, just you add the two equations in a simple beyond that IGCSE work. So 1 plus 2. Or you can solve it by using calculator. I just do it manually. 1 plus 2 is 2t1 minus t2 plus t2 will get cancelled. So 2t1 will be equal to 750 into 9.8 plus 3000 pi square. So t1 will be equal to 18,479 Newton. That is 18.5 kilonewton. So that's the tension of the upper arm. That's the A part, first part. So I'm answering A part. That's the answer for the first part. So anyway, A part, first part, that's the answer. A part, second part, they have to find the tension of the lower arm. So that is T2, substitute in one of these equations. So from equation, either one of it, 2, substitute, you'll get the answer. T2 is equal to 11,130 Newton. That is 11.1 kilometer. Okay, so B part of this question. So these are the first part, A part, first part, second part, tensions of the upper arm and the lower arm. B part state how this would affect the sum of the tensions, addition of the tensions in two arms when the length becomes 5.1. So due to I told that when it moves on a circular path, the C will have intention of moving away from the center. So both arms AC and BC will have tension because C will move away from the center. So now they have extension, they have become 5.1 meters. There's an extension of 0.1 meter. What will happen to the sum of the tensions they are asking? So accordingly, you can use these equations. This equation you can use this one. When the arms becomes larger, R will increase. When the 5.1 means R will become larger. So when the radius becomes larger, sum of the tensions will increase. That's the answer, nothing else, 2 marks. You can say when the first mark you can get by saying when the length of the arms increases, radius of the circular orbit will increase. When the radius of the circular orbit increases, according to this equation, you can write this equation, according to this equation, the sum of the tensions also will increase.